Hello, Professor Sargent here with you again. Now we're going to take a look at solving 3 by 3 linear systems. And the idea here is by elimination to go from a 3 by 3 system to a 2 by 2 system, and then you use elimination again on the 2 by 2 system to get one equation with one variable. Now, there's a point I want to make, and so I'm not going to go with what might be quicker here. I'm not going to go for efficiency. Instead, I'm going to notice that we've got a 2x versus a 1x in both of the others. So I'm going to use equation 1 as a focus or working equation, focusing on getting x to cancel out. So I'll do that by multiplying equation 2 by -2, and then add equation 1 to that. Similarly, I will add -2 times equation 3 and add equation 1 to that. So I'm multiplying equation 2 by -2, and then I'm adding equation 1. This is my own notation here. That's going to get x's to cancel. We'll take equation 3 by -2 as well, and add equation 1 to that. So let's see here. Somehow that erased that. So here's equation 2 multiplied by -2. All terms on both sides multiplied by -2. So now add equation 1. Leaving that one alone, I'm not multiplying it by anything. Our x's cancel, and we have -17y plus 42z equals -9. Whereas if we multiply equation 3 by -2, all terms on both sides of that, plus a 12z, and multiply the -22 by -2 as well. We're adding to that equation 1 left alone. So that was 2x minus 7y plus 30z equals 1. Let's add those. Add the like terms along the columns, and we wind up with y plus 42z equals 45. Now, by the way, what we've done is created a 2 by 2 subsystem within there. So I could write another question, same equation 1, and then our new equations that just have y and z. That's an equivalent 3 by 3 system, meaning that if there's a single solution to the original, then it is also that ordered triple would be a single solution to this system as well. And this is an easier system because the new second and third equations don't have x in there. We've got a 2 by 2 subsystem within that. Okay, so we've got the second and third equations here do not have x. And better yet, we've got a 42z in both of those. If I take my new equation 2 and multiply that by -1, multiplied by -1, again, this is my own notation, add that to equation 3, then we've got 17y minus 42z equals 9. Again, don't forget to multiply all terms of that equation on both sides by that same constant. And we're going to add that to y plus 42z equals 45. We're going to get the 42z's to cancel, leaving us with 18y equals 54. 54 is a multiple of 18. Dividing both sides by 18, we get that y is equal to 3. So we've really got now, we could copy down equation 1 and equation 2 and write a new system, 3 by 3 linear system, that is equivalent to the first and the second systems. Now that we know that y is equal to 3, we can put it into that second equation. -17 times 3 is -51. Adding 51 to both sides, we've got that 42z equals 42. And dividing both sides by 42, we now know also that z is equal to 1. Plug both y and z into that first equation, and we'll have what x is. So 2x minus 7 times the 3 for y, minus 21, plus 30 times the 1. 30 times 1, of course, is 30. And that equals 1. So 2x minus plus 9 equals 1. Subtract the 9 from both sides. 2x equals -8. And dividing both sides by 2, we've got that x is equal to -4. As an ordered pair, that's -4, comma 3, comma 1. And it'd be worth going back to the original system to check. In equation 1, Well, we just used that to get the value of x. So let's check with equations 2 and equations 3. Again, our solution here was supposed to be -4, 3, 1. So on that second equation, 5 times 3 is 15. 6 times 1 is 6. It's going to add up to 11 minus 6, or 5, which is what we wanted on the right-hand side of equation 2. And subtracting 4 times 3, it's going to be -16 minus 6, or -22, which is indeed what we have in equation 3. So yes, we do have that -4, 3, 1 is the solution to this 3 by 3 system, linear system of equations. That's all for now, and I'll see you soon with another one in another video. Press the like button, and to sound hip like the youngins, smash that subscribe button.